Hello everyone. Today we are going to see about NumPy in Python programming, numerical Python. So we are going to give some introduction and then we go for programming. So NumPy is about numerical Python and it allow you to carry out array processing, multidimensional array processing with more inbuilt manipulation and transforming functions available, which is more efficient than traditional arrays in Python. Every Python module has its own array functions, array module, but this NumPy is a special package and that can be imported. Uh, when comparing the performance of traditional array, this numerical Python has good performance. That is the case. It is having its own importance in scientific computing and other areas of applications. And it is a open source. You can download the package and you can import. You can readily use the features. What are all the features available in NumPy? It's about it is capable of handling n-dimensional array. So not only n-dimensional array, also functions to access n-dimensional array is available. And you can integrate this NumPy with other high-level programming languages. In general areas where it can be applicable is to solve linear algebra problems, Fourier transform problems, and random number capabilities. And this is the case, this is the statistics that shows how the computational speed is higher when you are using numerical Python over Python list and arrays. It has major impact in the computational speed. So NumPy arrays are chosen over traditional Python arrays. Generally, array can be defined as a set of data items of similar data type. So an array is a data type used to store multiple values using single identifier. What it can, a single variable can hold a single value, but in array, a single variable can hold multiple values and it is going to be accessed through indexing. We will be giving indexing to the variables like a of 0, a of 1, a of 2. In such a way, the a variable can hold multiple values. All are going to be a ordered collection of elements and it is going to be same type, right? See, this is an example. So you can consider this as a single dimensional array. The indexing starts from here and it is default 0, 1, 2, 3, and 4. So I can access the name of the array with indexing to specify the particular data. Also, NumPy array can be created to store list of numerical data, vectors, and matrices. Also, it is having its own built-in functions for manipulating and transforming the NumPy arrays. And here, NumPy array in Python is usually called it as ND array. ND array is nothing but n-dimensional arrays. Okay, now multiple dimensional arrays. This is the package. You can import this package and you can start using all the functions and other properties with respect to numerical Python in your Python code. More than that, array can be created in different ways. One, you can use library functions of Python. Another one, you can use this, that is Python data structures. List can be directly used and you can convert them into array. Otherwise, you can go for this, that is numerical Python. You can import numerical Python and you can directly use the declaration, manipulation, and other kind of. I'll show you the implementation of array that is using NumPy. Okay, let us go for the implementation. Give me a minute. So we can go for, yes. Here, if you see, if you see this, this is your Jupyter notebook and I'm going to show you the way how can you define, how can you import the package, and how can you create an array using NumPy function. So here your actual NumPy package has been imported and default variable is created. And this is your array creation. You have to create a variable and np.array. This is a way you can create your n-dimensional array. np.array and list of numbers in a square bracket. List of numbers in a square bracket specifies there is only one list, so it specifies it is going to be a one-dimensional array. Similarly, another variable called b, and it is calling np.array with two sets of values, two set of list, and it specifies it as a two-dimensional array. And I'm just printing the thing which I have created here. When I print it, I can able to get that this is a single dimensional array and this is a two-dimensional array. Right? This is a simple way to create a array and user has given the values here. And some inbuilt properties are available with NumPy. How do you call them? Just by the name of the array dot your property. Name of the array dot your property. This shape will retrieve rows and columns of the array. And here B is 2 cross 2 that is array. So 2 rows, 2 columns available. The output is like this. And similarly here, let me give me a minute. Let us take time. I'll be showing you the runtime. Yes. This is about dimensions. Dimensions are nothing but if I choose A, it's going to be one dimension. Okay. I'll be declaring it. I'll once again run all these things. Wait. Now I run this. So this will give you the dimension. A is an array of single dimension, so it is giving 1. If I change it as B, then I can get 2. So dimension of the array is displayed. And type of the data. What is the type of the data stored? And this is the size of the data. Total number of elements. If I access A array, it's going to be 3 numbers. And B array is having 4 numbers in total. Okay. And some inbuilt functions are there. Those are zeros, ones, empty, arrange, arrange, and linspace. Zeros will create n number of zeros with respect to rows and columns. This will specify the row and this will specify the column. Okay. In that case, these many row and these many column zeros will be created. In this case, 1 row, 3 column zeros are created. Similarly, here ones will create all ones with 3 rows and 3 columns. See here, right? And empty will create some array of space, 2 row and 2 column. Some default garbage value will be there here because I didn't specify any values. Only memory allocation has been made with the empty array. Later it can be used further. But it is accommodating some garbage value. Okay. Then A range. A range is, I'll be giving the starting number and ending range and also the partition. How many, that is the difference. The difference between the numbers has been given. From 0 to 10, the values has to be generated with the difference of 2.5. See the difference. This is the code 0 to 10 and the difference is 2.5. If I'm giving it as 2, let us check what is the output. See, 246. Sorry. 0 to 0 to 468. This 10 is that is end value is excluded, only it is including the starting number and with the range difference of 2. And length space is similar to the thing in the structure, but the last parameter is completely different. This last parameter, what it does, it will divide the ranges into 5 partitions. If I'm giving 0 to 1 and the partition is 5, the output will be like this. 5 numbers will be displayed and the partition will be happening equally, equal partitioning 0.50, 0.25. This difference is 0.25, and again this difference is 0.25, and this difference is also 0.25. If I can give it as 10, 10 numbers has to be generated from where to where? 0 to 1. So 0 to 1, 10 numbers has to be generated with equal distance, So that is what linspace. These are all inbuilt functions available in NumPy. Then some basic operations with the array. Already we have created array A, and when I declare a operation like this, A is array plus I'm creating a new array with same number of elements. This NumPy package can be able to do this element-wise addition. See the output, this is your A, and the sum is made like this. Number to number addition has been done. Similarly, when you take product, the A is the array, and I'm just doing multiplication with 2. Element-wise multiplication is happening. And also for exponential operation and also for square operation. So when I do this exponential, every individual element in the A is get exponential value. Every individual element in the array A is going to be square root. So that is the output here. Then some advanced operations with array: join, split, search, and then sort. What does it mean? Join. So join is nothing but you're going to concatenate. You're going to combine the arrays. In such a case, I have an array already created A. I'm just going to concatenate some set of values with the A. In that case, 4 and 5 is going to be added along with already created 1, 2, 3. Just what I'm doing, I'm just concatenating. And it is possible to split it. Already array has been created and I'm going to split it. How do I split? The value of array is now 1 to 5. Value of array is 1 to 5. I am just giving the size. How many arrays, sub-arrays has to be created. Sub-arrays to be 3 in count. In that case, equal division is not possible as it is 5 in numbers. So first array is of 2 numbers, second array of next to 2 numbers, and the last one is having only 1 number. Okay, this is split operation. And then search index. I can find out the value just by specifying the index number. So the condition has been given as joined equals to 4. Joined equals to 4 is nothing but you're going to check whether that is the value is having the same as 4. In that case, this is 0th index and this is first index and this is second index, this is fourth index. So in that case, it is retrieving the value as array of 3. Array of 3 is 0, 1, 2, 3. This is your value. This is your value which is equals to this 4. Fine. So that is retrieved. Array of 3 is having 4 as a value. Array of 3 is having 4 as a value. So that is going to be your output. Right? And then sort operation. You can sort the values. Already actually it is in sorted order. So there is no change. If it is not in the sorted order, it would have been changed. Okay. Then indexing, slicing, and iterating. So general indexing, as with the other traditional high-level languages, holds the indexing from 0 to n minus 1. Similarly, here also, it is going to do the same thing. So just if I change the index number, I can access different numbers here. So index position 3 is holding. Index position 3 is holding. What does it is? Let me check the error. Out of bound 5. So index position 2 is having value as 3. Okay, just by changing the index, I can access all the values. And slicing, what does mean slicing? Without specifying the end, that is starting and end number, I can access the values just by giving the starting number, and remaining number can be exist. Even I can give some end limit also. Likewise, I can create sublist from the list. array. Sublist can be created from the array. So slicing of 0 comma no numbers has been given. So it is taken default value and it is displaying that. Only it is having three numbers. So iteration are repeated till the end of the element. It is going to be 1, 2, 3. Fine. This is about your simple indexing, slicing, and iteration operation. Fine. So with this, I'm winding the session and reminding things like so some more that is accessing with the array NumPy can be continued in the next session.